Okay, so in the last video we took an overview of the types of questions that you can find on a AQA GCSE computer science paper, and this is the current spec paper, and the current spec is 8525, and the variant we're looking at now is the Python variant, which is paper 1B. These are details, and we didn't mention them really in the first video, but we'll just mention now that this is actually 85251B, which is the Python programming paper. Now, the most fun, the easiest, and the most interesting questions on these papers are the algorithm design questions, and these are the questions that many students get worried about, but they really don't need to. Just taking a look at the question itself, so we get a specification. This is what the program should do, and actually it's even bullet pointed. So oftentimes, if you just implement these bullet points one by one, you will land somewhere near an answer. The question is just, can you allow the user to enter a journey distance in kilometers, no validation is required, into the Python programming construct that it implies, which is some variable, maybe dis for distance, equal to the integer conversion of an input, with maybe some sensible message, distance, and then make sure to close all the brackets. So that on its own will get you 2 marks. Usually, choosing an appropriate variable and appropriate variable name, doing the conversion to integer data type, and getting the user input. So usually that'll be 2 marks just for that single line. If you get very expert at simply writing down this structure consistently with an eye for the data type, that is sometimes worth as much as 10 marks on a paper like this. That is more than 10% of the marks for this single line of code. I don't encourage students to jump right ahead and start writing code like this, but I've just given that as a preview. What I instead will tell students to do, and it is still the way I think about it, is I'm trying to look for the 4 things that a program can do. So there's only 4 kind of qualitatively different things that I can even do in programming. It's a very simple discipline. All the complexity comes out of how I combine these different constructs. So the first and most obvious thing that we've discussed already is a program can do input and output. And so, to be clear, I am not writing code yet. I am speccing out my program, and the process of planning your programming is by far the most important skill. You never start an essay without writing a plan. You should never start a program without writing a plan. The difference between us and chimpanzees is that we can plan. It's not identified in almost any other way other than our ability to think ahead with our planning skills. So let's go through this. So we need input, output. A program can also decide. So a program can decide between 2 different options. There's constructs for that, but this is a very important idea. We can decide between 2 different things, given a condition. And we can also loop or repeat, but I'm going to use the word iterate because I'm going to stay technical. Although it's fine to refer to it as repeat or loop, depending on the needs of your students. And then the final thing, which is a little bit more complicated and usually is more of a bridge to A-level, we can decide what the data structure is. And in GCSE, we'll talk a lot about data types. And at that moment, I would ask the class, what are your 4 data types? And they would tell me back integer float for the numbers and string and Boolean for the more exotic ones. That needs, all of this knowledge needs to be ready at the drop of a hat. We can't be reteaching these ideas in a programming lesson. So assign, let's add it just for now. Assign correct data type to variable. Now, I probably wouldn't word it just like that, but I am for prospective teachers, I am going to talk about that idea of the variable, choosing the data type and assigning it correctly. And this one will grow with us on our way through to A-level, whereas honestly the others are pretty much the finished outcome. So input output decisions, iteration, you'll be using those for the rest of your career. The only one I would argue that really gets more sophisticated is the data type as you move into your A-level and further into your career. Okay, these are the 4 things we can do. So for now, just for ease, if we just give them numbers, so 1, and let's see if my pen will allow me to give every single one a different color to make it even clearer. And then let's go for still something visible. Let's go for red. Okay, so for each of the spec points, we should try and think about which one of these 4 it's going to address. So input output, well, that's the first one, isn't it? This first one does input output. And it also asks us, and I'm aware that this is gonna end up with being a slightly different color. I'll just adjust this color. This will end up being more than one of the points. This one here, this first spec point, will actually be about the variables as well. So let's give it this one as well. Allow the user to enter the number of passengers. No validation is required. So again, this is really just the same. So this is 4 and 1. Calculate the taxi fare by charging £2 for every passenger, regardless of the distance, charging a further £1.50 for every kilometre, regardless of how many passengers there are. Okay, so there's 2 sub-spec points here, and this is going to be where we have to earn our money and make a decision. And maybe the clue is in me saying that. So charging £2 for every passenger regardless of the distance. £2 for every passenger regardless of the distance. Well, okay, we're going to ask them for the distance. We're going to ask them for the number of passengers. And then we're just going to add 2. Right? Then we're just going to add 2. But also this word every is an interesting word. Every. Now, every is hinting to me that I might have to repeat something. I might have to repeat something because I'm going to do something for every. Okay, so I can always rub this out if I'm wrong, but that's telling me I might need to do some iteration, charging a further £1.50 for every kilometre, regardless of how many passengers there are. Now, charging a further £1.50 for every kilometre, regardless of how many passengers there are. Okay, I don't think I'm going to have any other iteration there. I don't think I'm going to have to repeat anything else there. Charging a further £1.50 for every kilometre, regardless of how many passengers there are. So £2 for every passenger, so 2 times the number of passengers, and £1.50 for every kilometre. Okay, maybe actually maybe I don't even need the iteration. This might just be a calculation. I might just need to take these two values and multiply them by the value. And then finally I've got my output, which is going to be the easiest of all of them. And I can identify that as output. So let's have a look. I don't remember what I gave it. Was it this one that I chose? Probably not. Yep, okay, it is. Okay, so actually I'm not sure I'm going to need to iterate at all. So let's take a go at this, right? We've done enough planning. We're going to need input. We're going to need two lots of input. We're going to need some sort of calculation, and we're going to output the value of that calculation. So the first thing they're going to enter is distance. Now I'm going to use the indentation, even though in this case I'm not sure I need any indentation. So dist, I wrote it before, equals converts the value of the inputs if you don't know what the data type of input natively without conversion, then you need to revise that. The answer is string, but you need that off the top of your head. And then number of passengers, I'm going to say pass equals, again, this is also a number. And I've just realized why. This question has more marks, because actually I've got it wrong already, haven't I? And probably you knew this from the beginning of the video. Distance isn't necessarily an integer. I think that's the trap. That's why this is worth so many marks. Distance will in fact be a decimal, which we'll represent as a float. And then I'm going to do all of the final bits in a single line, and I'm going to write print cost, and then we're going to do dist multiplied by 2. And then plus pass multiplied by 1.5. And I made another mistake. But Python might let me get away with it. So the other mistake is, even if my passenger is an integer, if I multiply it by 1.5, in some languages, it won't matter, because I'm not storing it to another variable. So this is okay. Okay, so that's the end of this question. The key things to learn from this question: input, output, decisions, iterate, and variables. Now, sometimes I will replace the discussion of data types and variables. Sometimes I will replace this with, let's choose another color. Sometimes I will replace this with talking about a different idea, which is doing a calculation. It depends on the group. You see that in this example, doing a calculation would have been a good thing maybe to have looked at, and maybe we could have thought about the data type as an afterthought, but actually maybe not. So actually, if I had this extra case, then I would have thought about this one as number 5 and this one as number 5. It depends how many things you think your group can cope with. But yeah, this is the key idea. Programming is actually the simplest thing in the world. It's all just the application of either somewhere between 3 and 5 rules. And this model is the same model I will use in a programming interview to at Google, or it's the same model that I'll use in an A-level class. It's the same model I'll use with GCSE. This is the only way of teaching programming that I've ever needed. I don't need anything else. So hopefully this has helped you learn how to answer these types of questions, and also hopefully it's given you an idea of how you can scaffold the idea of teaching, the idea of programming, and the idea of learning programming into some very simple structures. Okay, in the next video we will look at tracing.